Okay, picking up from the last video, I had mentioned that I added this little expansion card to my Zynq board, and that's essentially given me an additional HDMI input-output and then a VGA output. And in the last video, I was just using this, since this was a new addition, as my primary output of Petalinux, just to validate that the hardware appeared to be working and everything seemed to be running fine. Since the last video, I've moved Petalinux to output back over this onboard primary HDMI output, and I'm going to use this one as really just trying to learn some programmable logic on video stuff that I can do, and output HDMI there, or do the same and output VGA over here. Now, at this point, I do have all three of these working. And so what you see right here, this window is the primary output right here. And again, I've got a separate keyboard mouse that I can work with over here if I'd like to do so. For example, open up a terminal or get out of this environment if I want to do something just in the console. Then over here to the right, in the upper right, this is a VGA output, and that's this one right here that you're seeing that signal being generated, and that's using a 16 bits total color that I can work with on that. And then this is the captured output coming from this HDMI. Now, the nice thing about that output is it is a true HDMI signal, so I'm not doing like a DVI signal out. It's an actual HDMI with support for audio, and I'm running all three simultaneously. And obviously this environment over here, this Wayland Weston environment, is really slow, but the stuff over here is all being generated out of programmable logic. So whatever it's doing really is having no performance overhead to my system at all. It's all on the FPGA side. Now, walking through, the VGA output, maybe I'll come back to that in a minute. This HDMI output, though, I wanted to have something that I could bring into my main Vivado project, and this is that project. And if you've been following, some of these videos as I go, you've probably seen this take some turns as far as how I've got it laid out when I'm doing in it. But in the last video, this entire section I had duplicated above it for that secondary HDMI output just to test that hardware. But since then, I really, and actually it's this entire piece right here, I've deleted all of that was in here, and I've just added in some new stuff. And this is the new stuff I added in. So basically, I now have a component in here, an IP component, where I can go do a plus, and I can say I want to bring in this HDMI IP, and basically then I can just wire up to it a pixel clock that's 5 times the speed. Those are both required inputs. Then also a clock for the audio, which I'm bringing in a 48 kilohertz audio there. And then a reset line, which is incorrectly marked as an active low. This is an active high, but I've just simply tied it low to say don't reset. Not yet, I'll tie that in later. And then I'm outputting a TMDS clock, and I'm doing a differential, so I have a positive and a negative, and then same with the 3 data lines or pairs of positive and negative for the differentials there. So I've got 4 pairs of differentials to cover those signals. And those signals are what I then have in my constraint file for that secondary HDMI. So I've marked those as using this IO standard TMDS 33 and mapped that to basically the ports or these pin identifiers that you see right here. And those pins then connect up to these pins on this expansion port that I have at the top of my board. And that's how it gets up ultimately to the HDMI output. But coming into this diagram, this is IP. So then the question is, what in the world is that? And I I had previously found and bookmarked something that was on my list to come back to. And in my last video, one of you commented that I should go take a look at this. And it is this here. It's a GitHub, and Samir has posted basically an HDMI, support for HDMI output and not doing DVI. So not a DVI signal, but a true HDMI signal with audio support. And like his video here is showing a 720 by 480, sample output, but he goes through how to use it and gives some nice helpful information here. And so a really nice GitHub page here. So I definitely have appreciated finding this, and it's helping me do what you see over here to the right. And what I'm doing over to the right, again, is I have a red line on the left border, a blue line on the right border, and then I have a green up top, and there's a blue, you can barely see it, or I can barely see it. There's also a blue on the bottom edge. And his test pattern, the basic test just to get going, pulls up that border. I then just added in some support to do some of this just kind of scrolling, waving color, which is kind of annoying, but I wanted something just to see some movement and some other colors show up on the screen. So he's got the source there. Well, I went out and created a new Vivado project, and that would be this project. And I brought over his source, which is basically this HDMI file and everything that's underneath this. So there's a whole bunch of files. I brought those into a new project. And then he also provides a top file, just kind of a really simple top file to get going. And so I can go grab the source files here. So that's where those all are. I can go to top, and he has a top file, just looks like this. Basically, it's just using that HDMI. Now he did his all of this in System Verilog. So he's then using this HDMI module, telling it to use video ID code number 1, which is the resolution that he's doing with whatever refresh rate, audio rate, etc. And then this is his test pattern. That's that border that goes around the red, left, green top, blue, right, and bottom is what that System Verilog is doing. So I brought in his top, and I modified it, and I guess the big changes I did is, as I get into this, I'm sending it video ID code 4 instead of 1, and that's because code 4 is for a 1280 by 720 signal with a 60 hertz refresh rate I specified here. And I also inserted some extra stuff just to generate that middle moving part of this over here. I just added some stuff to do some, just grab some color bars and slide them over, and whatever that effect is. And I didn't put too much energy into that, so I'm sure there's some much cooler stuff I could do later. But that's the top I built, and I built that real quick in System Verilog. Then what I wanted to do is just take that work and say, okay, I want to get that in my other project. So I did a create and package a new IP. But one of the things I found there is you cannot package something with the top being a System Verilog. It's got to be Verilog or VHDL. And so I created a quick wrapper in Verilog that just wraps his top that I customized. Now, something else I noticed with what I pulled from GitHub of his was that he's only providing the positive, if I understood it right, but only the positive signal for the clock for TMDS, and only the positive signals for the 3 data, data lines or data pairs. So I did come in here and I added in some additional things in my wrapper, basically just to say, okay, that clock, I want it to be a differential pair. So take the clock he's providing, or basically, giving as an output here, and I want to output that clock in a differential pair. So this is my TMDS clock, and I'm outputting the positive and the negative. So I take it, and then I have a positive, negative. And then I did the same thing for the 3 data lines. So down here, just grabbing the data line 0, 1, and 2, and sending them out as a differential pair, a positive and a negative. So that was a minor tweak that I wanted to have the differential pair and not just the positives. But once you get all that done, you can come in here and do a run implementation. Just make sure it gets that far. You don't have to do the bit stream or anything. But I do the run implementation, and then you can do a create and package a new IP. And so then you get into this wizard and you say package this project, and you point to where you want to save it. And I've been saving into a folder called custom IP, and this one here. So I made a HDMI IP, and I would select that and overwrite it since I've already got it there. But once it's there, I can go to my other project right here, and I can go to the settings, and I can go to the repository and do a plus and point to that folder, which I've done, and you can see that right here. So I've said, okay, add that as IP. That should show up in my system. So I can now do a plus, and I can go fetch it and just simply bring out this right here. Now, something similar I did with my VGA at the bottom, but it looks different. You notice it says RTL. That's because in my project, I have the Verilog that does my VGA output. And, I can expand all of this and see all the modules. And then I just come in here and I had said, well, right click and add module. And I pointed to that. Now you can't point to system Verilog though. And you're supposed to be able to wrap it with Verilog and then add it. I tried that and I could not, it wasn't working for me for whatever reason. So that's why I ultimately put it into IP, but now I can add the IP. Now it shows up like this. I needed a couple clocks, so I got a clocking wizard and I set up those clocks, the 74.25 and a 371.25. So where did I get that number? In his write-up, Samir is kind enough to put in the frequencies. So if I want to run 1280 by 720 and 60 hertz for the refresh, I could pick one of these other ones if I wanted, but I wanted 60. That is, first of all, video ID code 4, so remember that. But then the pixel clock is 74.25. And the other clock you need needs to be 5 times that. So 74.25 times 5 is my 371.25. That's my 2 clocks coming into this, along with a 48 kilohertz clock for audio, which I just simply pulled off of my, I'm doing other audio stuff already in my system, so I just pulled it off of the, it's the left-right clock on my audio setup, but that's the same as the 48 kilohertz. And then the reset is incorrectly shown as an active low. This is actually an active high, so I'll tweak that later. I just set it to never do a reset, which is fine for now. And then all my outputs. So I've got my clock positive, negative. I got my data line positive and negative, all 3 of those. And I connect them up. I have my constraints file that then has, the appropriate lines to connect all of those to the specific pins I'm using. And then I build that, and that's what I then brought into my Petalinux and rebuilt my Petalinux image, and I've booted off of that Petalinux image, so that's sitting in this SD card here. So I turn on my system, I boot to that, and very quickly you'll see that these 2 outputs will be running because they're programmable logic. And this output won't run until all the appropriate drivers and things are loaded up in Petalinux. And I could probably show you what that looks like. So if I'm over here, I'll switch keyboards here. I don't know if I can do this from in here. Let's try it. Let's do a sudo reboot. And either I didn't know my password, or actually this is probably for the wrong user. Let me just kick out of here. Let me log in, and I'll do a reboot. And you'll see that when it reboots, and I can probably pull up my little camera of my board at the same time. I'll just leave this down here. If you see lights flashing down on here, this would be my USB serial activity. So, it's booting up. This is showing that, please wait, booting as it's loading up Petalinux. And then at some point it will get this Weston Wayland environment up and running. Like so. But I'm going to kick out of that and do this one more time, or maybe I'll be less nice. I'll just hit this reset here. And as soon as I do that, I lose all 3 video outputs. And then you can see this one up here comes up really quickly, followed by my VGA. And then as the boot gets a little bit further along, it'll get enough support to give me some text output up here, which we should see shortly. There's the please wait booting. And then it's got a bunch more stuff to do here before I can actually get into that graphical environment on my Petalinux. But now the nice thing is, I can come in here and on this board, I've got this VGA output showing this over here. I've got HDMI using an actual HDMI signal with audio support coming out over here. Both of those are being driven off the programmable logic at this point. And then I have this one being driven. Obviously, it's using programmable logic as part of it, but I'm really using it through Petalinux, which requires all the drivers and Petalinux and everything like that to get loaded up and working. So again, if I hit reset, you can kind of watch speeds on these as this stuff gets going right away with my VGA very quickly to follow with a much longer delay than into Petalinux. But I went out, I grabbed essentially the source from this project here along with the top file. I created a Vivado project. I brought that in. I added my own maybe flavor to the top module. I then wrapped it with Verilog. And then I created a new IP. I came to my other project. I added that IP. I connected it up. And off it goes. Now, obviously, this is just simply loading up the entire top and testing and everything inside of this IP. That doesn't make much sense long term. So what I'll work on probably next is, instead of within this, having all of the test code, can I say hard coded? I want to add in parameters to control things, and maybe I can add an AXI stream, 2 AXI streams, maybe one for audio, one for video. I'll have to see how this works. But then I can maybe control that AXI stream from maybe an app that I can write that could run inside of Petalinux. So in here, I could have an app that could do something with an AXI stream, maybe just set either parameters or actually video data, audio data, whatever it might be, and then have that get used by this IP. So I've got some work to do there, but this will change, I think, as I go forward to have some more things, hopefully some AXI stream type of stuff, or AXI 4 interface, I think in general, whether it's, I think there's a few flavors, stream and couple others, but anyways, I have a lot to learn there, and I will do some experimenting with that and see what can I learn. I will do some more work with AXI 4, see if I can get that tapped in here, and see if I can eventually get to the point that from Petalinux I can do some manipulation of graphical output on these two, the VGA and secondary HDMI. I have a lot to learn, more to come, so stay tuned.